how reliable is your measurement system? If you work in manufacturing, automotive, or quality control, you need to know this. Why? Because if your measurement system isn't reliable, your data is worthless. Imagine making decisions based on bad measurements. That's a disaster. In any industry, a robust and reliable measurement system is essential for decision making. Welcome to this tutorial from SPC Consulting Group. Today we're diving into Gage R&R, one of the most critical MSA, or Measurement Systems Analysis tool in the core quality tools. We'll break it down step by step, and by the end, I'll show you an easy way to calculate Gage R&R using Minitab. Gage R&R stands for Gauge Repeatability and Reproducibility. It's a method used to evaluate the reliability of a measurement system by checking two key aspects. Repeatability. Can the same operator get the same measurement every time? Reproducibility. Can different operators get the same measurement on the same part? In this type of study, measurement equipment is evaluated for repeatability, while operators are evaluated for reproducibility. If your Gage R&R is bad, your measurements are inconsistent, and you're introducing variation into your process, which leads to quality issues and scrap. Now, let's go step by step. For this type of study, we need 10 parts, 3 operators, and each part must be measured 3 times by each operator. The parts should be selected from the production process, ensuring they cover the full operating range and tolerance specified in the drawing. First step, measurement process. In this example, we're working with a piston, and we'll use its largest outer diameter as the critical characteristic. Here, you can see the 10 selected parts on screen. Each part must be identified from 1 to 10, but without marking them directly, as operators should not know which part they are measuring to avoid bias. The person leading the study, who could be a metrology coordinator, product engineer, or quality engineer, is responsible for organizing and assigning the measurements randomly. We'll have 3 operators, and ideally, these should be people who regularly use the measuring equipment, not engineers or quality managers. The study leader will provide the parts to each operator in a random order. For example, operator 1 might be asked to measure part 4, then 7, then 1, then 10, then 5, and so on, until all 10 parts have been measured. This completes operator 1's first trial. Each operator must only measure and report the result. They should never know which specific part they are measuring. The study leader will record the values in a spreadsheet, either manually or in Excel. Once operator 1 completes their first trial, operator 2 will follow the same process, then operator 3. This process is repeated 3 times per operator, but not consecutively. In other words, operator 1 completes their first trial. Then, operators 2 and 3 take their turns before operator 1 returns for their second trial. This approach follows a crossed study design, which is why Minitab refers to it as a crossed Gage R&R study. Once all measurements are collected, the data is organized in an Excel table. Second step, entering data in Minitab. Minitab can create the Gage R&R worksheet. However, we will structure the data as follows. Operator column. Each operator performed 30 measurements, so we list their number, 1, 2, and 3, 30 times in this column. Part column. Parts are listed 1 through 10, repeated 3 times since each was measured 3 times by each operator. Results column. The actual measurement results are entered in the order they were collected. This data comes directly from our Excel template. There are other ways to randomize the data. It is important to assure the relation between part, operator, and measurement. Now, let's go to Minitab's menu. Click Stat, Quality Tools, Gauge Study, Gage R&R Study, crossed. In the pop-up window, enter C2 and parts number, since that's where we listed the part numbers in our spreadsheet. Operators in the corresponding column, and measurement data in the column with the results. Ensure that ANOVA, Analysis of Variance, is selected. This is the most commonly used method in the automotive industry. However, please review your quality manual to verify that ANOVA is established as the method of analysis. Click OK to generate the results. Third step, analyzing the results. Minitab provides both graphical and numerical results. But it's important to note that graphs are not used to determine whether the Gage R&R is acceptable. The graphs are going to be analyzed to understand the system variation and determine actions to fix a poor measurement system. Instead, we focus on the numerical results. The acceptance criteria for a Gage R&R study are as follows. If the percentage of total variation is less than or equal to 10%, the measurement system is considered excellent. If the percentage falls between 10 and 30%, the system is acceptable, but there is room for improvement. However, if the percentage is above 30%, the measurement system is unacceptable, indicating significant issues that need to be addressed. In this case, our study shows a total Gage R&R of 4.93%, with 28 distinct categories, indicating a highly reliable measurement system. Additionally, we can see repeatability with 4.91% and reproducibility with 0.37%. Minitab also provides details and other statistical factors used for deeper analysis. If your Gage R&R is bad, here's what could be wrong. Poor repeatability? Your gauge might be unreliable. Check calibration. Poor reproducibility? Operators might need more training. Part variation? Make sure your sample set truly represents the process variation. Some common measurement system analysis issues include inadequate calibration, worn-out master parts, low-quality measuring instruments, application errors, ineffective resolution. Fixing these issues and redoing the study will help improve your measurement system and ensure accurate data. And that's it. With just a few steps, you can perform a Gage R&R analysis and determine whether your measurement system is reliable. Remember to focus on reducing both repeatability and reproducibility variation for better process control. If you have any questions, drop them in the comments below. Follow us on our social media for more content and updates. Give this video a thumbs up and subscribe to our channel for more quality improvement. Thanks for watching.